Good evening, sir. Hi guys, how are you doing this afternoon?
Six, sir.
Oh no, I just saw that I was in the chat. Never mind the rest. You want to go make some tea?
I'm having some soup.
Ah, make sure some chicken put in there now.
Yes, sir.
Yeah, that does wonders, trust me. Never mind, honey. All right, with all the maladies around, let us just get into the frame of mind for work. Trusting and believing that the big man up top will be with us as we deliberate in class tonight. So, outside of Charlie not feeling too well, but I mean, as soon as she finishes drinking her soup, she'll be much better. I am hoping and trusting that today would have been a very good day for you. And if it wasn't, that spending the next hour and 45 minutes thereabout together will somewhat bring some light to what it is that you are facing. I know today was a big day. I got up and said that I'm going to do my little Christmas something in trances and plan to wash cushion and wash this and wash that and say, yeah, bam, the rain came. So I'm giving thanks. Could have been worse, could have been much worse. But giving thanks. All right. So hoping that you are in the same sort of frame of mind as I am in terms of being thankful. I want us to continue with what it is that we're doing. Last two classes, we specifically looked at the integration of indefinite integrals. And then last week, I did one or two questions on the definite integrals. And that's what I want to spend a little bit of time on today. Just giving you some questions to integrate and asking you to integrate some definite integrals and see what will happen. I am almost sure that in that same light, I would have given you a few questions to do. Because I'm very confident, knowing me, that I wouldn't just send you on your jolly way without a question or two. True or false?
True, sir.
How many of us were able to look at those questions? I'm just trying to find them because you know what is very possible. I wrote those questions, sent them off to you, and have not done them myself. So
sir, I did all of them.
Very nice. Proud of you. Proud of you. All right, let us see if I can find those questions. Because they don't know what happened. Okay. I send you those questions. Integration. I sent you those questions and then They are not in my original document. Which date was our last class? Our last class was on the 25th. Okay, so let me go back to my calculus one. See if I can find oh no, I know why I can't find it. Because it wasn't a typed document. It was my handwriting, true or false?
True.
Sure. So, all right, so I made a blunder. So let me see if I can fix it. Semester 1, 4 plus 1, integration. All right, finding them now. Finding them now. All right, so I need to share this document. Come on. So that was 3. No, it is 2. All right, so that was the first question. The integral of x cubed plus 4x minus 5. And let us go through the integration. So, in integrating, I'm gonna have, okay, you should be able to see the screen. Don't worry about the black thing. All right, let me just put it over here so that we're not seeing anything at all. Great. Smart move. All right, so when I integrate x cubed, I'm gonna get x to the 4th over 4. Do you agree with that?
Yes, sir.
Now when I integrate 4x, I'm going to get 4x squared over 2. 4x squared divided by 2. Those who weren't in class, or those who weren't following, I'm going to ask you to pay some special attention to what is happening here, please, and thank you. I mean, I will call my friend Ryan's name at all. I refuse to call Ryan's name. This is what happens. I have my question here. And the question means to evaluate, E-V-A-L-U-A-T-E. Question means to evaluate that. No, it means that I have to first differentiate the function. And then when I differentiate the function, now I'm going to be applying my upper limit minus my lower limit. Differentiating the function is a breeze. Why is that, sir? Because remember, you always add 1 to the power and then divide by the new power. We're adding 1 to the power and then dividing by the new power. Adding 1 to the power, dividing by the new power. What do you mean, sir? We're adding 1 to the power and then dividing by the new power. So this is it. X cubed, I'm adding 1 to the power. So it becomes x to the 4th divided by the new power, 4. See here? This is 4x to the 1st. Adding 1 to the power, 4x squared divided by the 2. This is x to the 0. And I add 1 to 0, I'm going to get 1. So that's going to have 5x minus 5x. So the integration is inside here. But now I have to take into consideration the upper limit 3 and the lower limit 2. Take into the consideration the upper limit 3 and the lower limit 2. Oh, Lord of mercy, undo. So, in the function, anywhere in the function, I see x, I am going to substitute my upper limit. And anywhere in the function, I see x, again, I'll substitute my lower limit. So I don't understand what I mean. Now, what I'm saying to you is, this is my integrated function. Anywhere in the function I see x, I'm going to put the upper limit, which is all of this, minus the lower limit, which is going to be all of that. So I need to substitute now. So I'm going to substitute now. Remember, anywhere in the function I see x, I'm going to substitute my upper limit. And then anywhere in the function I see x, I'm going to substitute my lower limit. Yes, please, go ahead.
The middle equation, so wouldn't you simplify it? Our fraction?
Come on, I could, absolutely. Yeah.
All right, another question, sir. I have to put the 2 and the 3 at the square bracket?
Yeah.
Okay.
Good day, sir. You went through the answers already?
That's what I'm doing now.
Okay.
That's what am I doing now? All right, so my simplified answers there. So I'm breaking down this 2 into this 4 to give me 2x squares, and that's what I'm substituting in here. So yes, we have to put the upper limit and the lower limit here because we now need to indicate that we are finding the area between these two values, between 3 and 2. You notice I don't have them here again. Why don't I have them there, sir? Because I've already applied them into the function. Anywhere in the function I see x, I'm substituting 3. 3 to the 4th power over 4 plus 2 times 3 squares minus 5 times 3 minus the lower limit, which is 2 to the 4th over 4 plus 2 times 2 squares minus 5 times 2. So it's the upper limit minus the lower limit. And now we need to evaluate what all of that is going to be. What is 3 to the 4th? 8 to 1?
Yes, sir.
And 3 squares is 9. And 3 times 5 is 15. And 2 to the 4th is going to be 16. And so let's look at that one for me. And then now I'm going to be doing my two to 4, 4 to 8. I could have done that in some smaller steps, but I want to show people when they are going back exactly what it is that I did. 3 5 is 15. 2 9s are 18. 8 1 over 4 is just simply 8 1 over 4. All right, so this is what I have. So 8 1 over 4, I'm keeping it as 8 1 over 4. 2 times 9, 18. Negative 5 times 3 is negative 15. Minus 16 over 4 is 4. 2 squares is 4. And 4 times 2 is 8. And negative 5 times 2 is negative 10. All agreed?
Yes, sir.
All right, cool. 4 plus 8 is 12. 12 minus 10 is 2. 18 minus 15 is going to be 3. And that is going to be. All right, let me just see if it is the non-calculator version. So the LCM is going to be 4. And then, of course, the 3 is over 1. The LCM is 4. 4 into 4 goes 1 time. And 1 times 8 to 1 is 8 to 1. 1 into 4 goes 4 times. And 4 times 3 is 12. And all of that is over 4. And 8 to 1 plus 12 is 93. 93 over 4. (93 over 4 plus, minus 2. And again, I can do the LCM to see 4 into 4 goes 1 time. 4 into 4 goes 1 time. 1 times 93 is 93. And 1 into 4 goes 4 times, and 4 times 3 is 8. 93 minus 8 is going to be 82. That's 85 over 4. Everybody got 85 over 4?
Yes, sir.
Good job.
Sir,
Yes, please.
I had a slight error and I want to know. All right, for the negative 5x, I substitute the 3 instead of the 2. Why I choose the 2 instead?
All right.
Mhm.
Hold on 1 second. Let me just highlight where you are at. Where are you?
I did those parts correct, and I just got up at the top with the negative 5x. I substitute the 3 instead, 5 instead of the 2.
Where?
Right there, you just, yes, sir.
You substitute the 3?
Yeah, I put the 3 where the x is instead of the 2.
But you're supposed to for this one. But right here, say put the 3 right here, say same?
Yes.
Okay. No, because remember, Chris, when you integrate, having integrated the function, then you don't need to put in the upper limit minus the lower limit.
Yes, I did that.
Hold on.
Oh, I see what you're saying. I see the mistake.
Yeah, right. So that's why I put it here, because I recognize what it is that you did. So you can't wishy-washy just put in any limit as you feel like. It is going to be the upper limit first, and anywhere in the function you see x, the integrated function you see x, you're going to substitute the upper limit in it, in all of it. So watch me. You see an x here, so Krish, and an x right here, so and an x right here, so what happens? You see the 3 go right there, and the 3 go right here, and the 3 go right here?
Yes, sir.
And then minus now the lower limit. The same thing you did for the upper limit, you can do for the lower limit, but you can put in the lower limit value.
I don't know why. The only one I did was that the negative 5. That's the only one. I changed the other rest. I don't know what I was doing right there.
Yeah, man, fine, fair enough. But you see error now, though.
Yes, sir.
So negative 85 over 4 is our answer. Very good. Is there anyone else that has a challenge with that, or anybody else want to tell me that they got the answer too? So is Charlene alone do the work? Let me just get to trouble on the know. Davio.
I did the work, sir.
So talk to teacher and Davio.
Okay, I got the answer, sir.
Thank you, please, miss. Thank you, please. Remember, so we are family, you know. So you have to talk up in that art class. All right, let's go. Sean. Sean Anderson. Squared plus 2x negative 1. All right. So we are okay. Very good. Yan. Lexton, me no want no good evening from you. You don't work, Lexton? If you do my work, you can say good evening. But if you don't do the work, you can say good evening. Zidane, you too. You do the work, Zidane? Habla me. Somebody talk to me. Anybody, please. I'm feeling very lonely over this side.
Yes, sir, I did the homework.
Okay.
So no, sir, I was not the next class. I'm just going to see what you're doing to kind of grasp.
Okay. Andrew.
Yes, sir. I'm here.
I want you to be more than just here, though. You did the homework?
Yes, sir. Did two of them.
Okay. Are you okay with the 85/4?
Yes, sir.
Okay. Thank you, sir. Kels. You know you're not going to be in class when I don't call upon you, Kels. Talk to me, Kels.
Why, sir, may I allow the others to talk?
No, whatever. You're too cute. No, we want to hear from you, Kels.
No,
Talk.
sir, may I allow the others to talk?
Kelvita, you do my homework?
Yes.
You
Yes,
see?
sir.
That just seal it a while ago, you know. Do none, you know. That just seal it a while ago, but anyhow. All right, very good today. Germany did the homework.
Yep, as usual.
Okay, very good. Are you agreeing with the 85/4?
Come on,
Very nice.
straightforward.
Very nice. Lexton, talk to teacher.
The weekend and you kind of busy.
You know, man. We know Lexton. That's why you're so very silent, you know. Because me know when you do the homework coming out, you know.
Sir, I not get to touch my maths that weekend.
You go for Thanksgiving.
Huh? No, sir, I'm not for work. Basically all weekend.
Okay, so that means you can buy all of us a drinks. Anyhow, let's go. Nestor. Nestor T, answer me, please. Sean Anderson, I called you a long time, you know, boy. Nestor, Onika.
Present, sir.
Oh, you do?
Okay.
You did my homework?
I did it.
All right, good job. Smitoy, you did the homework? All right, so everybody, Shonali, you did the homework? All right, so everybody don't decide at the class. Shona?
I wasn't aware that we had received homework.
Okay, all right. Did you receive the document?
Now sticking to my fingers. Go back in your I saw the document, but I didn't look at it.
Okay, all right, thanks for your honesty. All right. Fraser, how you stay? Mr. Fraser, sir.
Yes, sir.
You do homework?
No,
Speak the
sir.
truth and speak it well. Cause it what it will. He who hides the wrong he did does the wrong thing still. Oh, your answer is no, you said, right?
Yes, sir.
This is 2 strikes, you know, Ramesh. 2 strikes, no, 2 times, no make your homework, you know, do it. All right, never mind. Students, I sat up last week, Thursday, and I said to myself, no, these guys did very well in class in understanding the indefinite integrals to the point where I was able to move into the definite integrals. And I sat up and I worked those questions, didn't write down the answer, but I worked them mentally to make sure that you can get an answer. And not everybody completed my work. It is not good. When work is given, I expect the work to be done. All right? I'm not going to hold this one against you, know. But next time around, I'm going to get mental. I want the work to be done. Remember, he who fails to prepare should prepare to fail. And the final thing I'll say to you on this, mathematics is not like POB or social studies, where you can read off a book in one night and go into the exam and get a distinction. It doesn't work like that. You have to put in the work. Put in the work. And I had an interesting conversation with one of your classmates today. If you miss something and don't put in the work, it is hard for you to move into something else because of the interconnectivity of the things that I'm doing and how it is that I structure your work. So I continuously build on information All right. And if I recognize that the foundation is not here, I'm not going to start building. I'm going to go over and over until I feel like you get the stuff, then I'm going to build. So don't let me finish the syllabus. When you only reach halfway in the syllabus, remember, if the students fail, no one can say that the teacher has not taught. That would be a lie out of the pit of hell. All right? So I'm going to ask you students, please, the sort of energy that you guys gave me in the first part of the thing is waning. You know, they have a saying like familiarity breeds content. So because you're accustomed to certain now, sure, we never go to class, or sure, we never log in and not say nothing, or sure, we never open the document, or sure, we never do the question then. No. First impression last, and I'm expecting much better from my students.
Even, sir.
Hey, what's up?
Late light bug.
Never mind, mommy. You know, anybody you know coming, you know. But let me ask you, though, you do my homework?
Sir, a long time.
Bless your heart. So I was just talking to your classmates about, you know, me giving work and them doing the work. You know, I don't want to get into a situation where the work is given and then surveying come do it. You see, the next time that happens, and una can't smarter than me. Yes, sir, we did the homework. Cause me call upon somebody randomly. And if the first person I call upon randomly don't do the homework, best believe that I'm going to say, those who do the homework, send me evidence of it, and then I'll send them the answer sheet. And I don't want to get there. I don't want to have two different classes. I want us to remain a family. So just do the something, man, please.
You gave the answers, sir?
I'm doing them now because I was looking for the questions and couldn't find them, but I remember that I was actually writing. So that is it. So the first one was 85/4. That you got that one? Sash?
Which number that, sir?
The first one, the very first one, the x cubed plus 4x minus 5.
X cubed plus 4x minus 5. 85/4.
Guess what?
No, sir.
What do you get?
I'll round it off to 78.
Okay, all right. Whoa. Round it off to 78. 78 meaning what?
Sir, I don't know what I do wrong. I have to go look over this. Unit square. You missed that one totally, Sash. I'm just double checking my answer right here. X cubed plus 4x minus 5.
Oh,
so I don't know what me do.
I just double check my answer. It's 85/4. Do you have the question, the working out in front of you?
Yes, sir.
See there? Look at the screen and tell me if you see where you went wrong.
Hold on a minute.
Remember, it's the upper limit minus the lower limit in a Sash.
Yeah.
And everywhere in the upper limit you see x, you're going to substitute the upper value. And everywhere in the integrated function, you see x again, you're substituting the lower limit.
So is it that you cancel out the 2 and
which 2?
that's why you get the 2x square?
But it doesn't matter though.
Oh.
This don't have anything to do with the question. I would have still gotten the answer if I'd allowed it to say 4x squared over 2. It's just make it simpler for me when I'm working out here. So that don't really affect it.
is. No, but it would make difference to me, sir.
Trust me, Sash. The values would just look a little bigger. You'd have had 3 3 is 9, 4 9 is 36, 36 over 2. So you'd have get 18. See, same 18. You see what I say? You'd have 36 over 2. But 36
That's
over
what
2
I
same.
have.
Yeah, same 18. 36 divided by 2, 18. That's me 18 on here, so same difference.
Hold on, give me a second, sir. Sir, me did sleep and wake up and do this, you know, so maybe sleep did not me I same way.
That happens to me a whole lot too. Do you have 81 over 4 for this one?
Yes.
And do you have the 18 or do you have the 36 over 2?
36 over 2.
And do you have minus 15?
Yeah.
Okay, for the other one you have 4? Or you have 16 over 4?
No, I have 8 over 4, 6 plus 16 over 2 minus 10.
You have 8 over 2?
8 over 4 plus 16 over 2 minus 10.
Okay, that's the problem. You can't get 8 over 4.
What is the square root? The 4.
It's
It should go to 4.
Right, the 2 is raised to the 4th power, Sash, and not to the 3rd power. You see, I got 8, but the only way you could get 8 is unless you have 2 to the 3rd power. But it's supposed to be 2 to the 4th power.
Okay, that's it. Oh my God, that's my mistake. Yeah.
So that's what you did, right?
Yeah.
All right. So I'm not. I'm going to move on because you see where you went wrong and you've gotten through most of the question already. Very nice. Just make that correction because you have everything else. Don't want to correct that 8 over 2, 8 over 4, 8 over 4. You should be fine and you should end up with the 85 over 4. Very good. All right. So we're moving on now to number 2. And number 2 says x squared plus 2x. The integral for the upper limit is -1. Upper limit is 1, and the lower limit is -1. So we're going to integrate our function. Integrating our function. And when I integrate my function, I'm going to get x cubed over 3 and 2x squares over 2. And that is between the limit -1 and up here says +1. So that's what I should have. Now look at it and tell me if you agree with me.
Yes, sir.
All right. Cool.
Yes, sir.
Nice. Anywhere in the function, I see that I'm going to put +1. That one is going to be -1. Look at what I have there. And then I'm going to evaluate those. But sir, Can't you reduce that? You always reduce it, so I never reduce this one. Yes, I can. So, seeing that I have done that, I need to remove the limits from that side. So I'm substituting the values. So I'm substituting the values. 1 is being substituted in here. So anywhere in the function I see 1, I'm substituting all of it in here. That is the integrated function. Then I'm going to subtract it from. I'm going to subtract the lower limit from it. So anywhere in the same function I see x, I'm going to put the lower limit. And then I'm doing my subtraction. Now 1 cubed is just 1 over 3. And 1 squares is 1. And negative 1 cubed is a negative 1. But negative 1 squares is a positive 1. So that is working out to be 2/3. And that is working out to be 2/3. What do you get for that answer?
Sir. So what you do with the negative 1? Negative 1 plus 1?
What about it?
So you get 2. You get 2. Because it would be technically, sir, 1 over 1. And if you find, I don't know.
No man, answer the question, because that's something I didn't finish off something right here.
Sir, I got 2 over 3 units squared.
Yeah man, 2 over 3 units squared is supposed to be the correct. That's supposed to be the correct answer.
Sir, I think it's the I think it's the 1 over 3 that you have over there plus the 1. It's like you get 4 over 3 instead of 2 over 3, right?
Oh, supposed to be 4 over 3. Oh, what is wrong with you? Supposed to be 4 over 3. And then negative 1/3 plus 1 is going to be 2/3. And then 4/3 minus 2/3 is going to be 2/3.
It is a 2/3, but
Yeah, so the error was right here. So this supposed to be should have been 4/3.
yes, sir, right now.
Yeah, man. So it's going to be 4/3 minus 2/3 is going to be equals to 2/3. All agreed? I know German same agree. And nobody disagrees. I know Charlene says she agree. And nobody disagree.
Yes, sir.
Very nice, very nice, very nice, very nice. Anybody disagrees? Where is that? Number 12. Anybody disagrees?
So I'm going to do something wrong, so.
Okay, but you see where you went wrong, right?
Yes, sir.
Good. No, let me just talk to you about that one. Now remember, and I forever will say it, sir is not interested in you getting the correct answer now, you know. There's a time for me now to say, Elvito, you need to get the correct answer. We're right about now, we're learning the topic. So what is important is for you to see your errors and then not make those errors anymore. All right, so I am not upset. I just want you to be able to see what is happening, but I don't understand this teacher of yours. Things are going all right, but him have to put in 2 over x squared. What is wrong with him? All right, never mind. This too shall pass. What we're doing right here is something similar to what we normally do. We're integrating. Whenever we're integrating, we're adding 1 to the power divided by the new power. But before we do that, we have to do a conversion, talk truth.
Rearrange, sir.
Very good. So we're going to rearrange something here. And let me just put a space right here because Sasha says, sir, I cannot see that. So when I rearrange, that's what I'm going to have. Talk truth.
Yes, sir.
Yes, sir.
So when I rearrange, you give me that now. Then now I can do my integration. And my integration says I'm adding 1 to the power and I am dividing by the new power. I'm adding 1 to the power and I'm dividing by the new power. I'm adding 1 to the power, dividing by the new power. Okay, sir, got you. Add 1 to the power. Then, sir, when you add 1 to -2, we get -1 don't. Yeah, man, every time. Then, sir, the ln function don't come into play right here. So, nope. The ln function only comes into play when it is at its raised to the -1st power. But, sir, it at the -1st power, no. That's fine because we just integrate it. But before we integrate it, if it had a -1 power, that we know we're going to have to get the ln function. But because it is raised to the -2, remember when I gave you the rules for integration? I said to you that if the function is raised to the -1st power, we have to use the natural logarithm. The ln function comes into play. But guess what? This is not raised to -1, it raised to -2. Is after we integrate it, we see the -1 pop up, but we're not business with that. We integrate it already. We're not business with that. We integrate it already. All right. Okay. So I'm adding 1 to the power divided by the new power. So this becomes 2x to the -1 over -1, 5x squared over 2, and -6x. Now, I'm going to be required to do my substitution of my upper limit and my lower limit. Of my upper limit and my lower limit. Oh Lord, this is going to be. Oh boy. A bit sick. This game for someone. A bit too. I hope it doesn't go. Then, sir, why you put it like that?
Sir, this is a new question or because I don't see this as a homework.
Come on, this is question number 3. I gave you
3.
5 questions. Yeah, I gave you 5 questions.
This looks like a total different question.
No, man. Remember, the original question is 2 over x squared. You know, the integral upper limit 2, lower limit 1. The integral of 2 over x squared plus 5x minus 6. You have to rearrange.
Sir, sleep definitely didn't make like a totally different question me out.
Never mind. Never mind. So we have to rearrange in order to get this denominator up to the numerator. So that negative, that x to the second power now becomes x to the negative second power. Right here, everything else remains the same. Then now I integrate. Remember, we are adding 1 to the power dividing by the new power. So it's going to be adding 1 to negative 2 is going to give a negative 1, divided by negative 1. Add 1 to the power 5x, I'm going to get 5x squared over 2. Add 1 to x to negative 6, and I'm going to get negative 6x. Whenever you have a whole number, just add an x to it. I hope you see that by now. All right, and then what I'm going to be doing next is to substitute my limits. My upper limit minus my lower limit. Always remember that your upper limit minus the lower limit. Anywhere in the integrated function, I see my upper limit. Anywhere in the integrated function, I see x, I'm going to substitute my upper limit. And then anywhere in the integrated function, I see x again, I'm going to substitute my lower limit. So it's going to be the upper limit minus the lower limit. Remember, it can't say lower limit minus upper limit. It has to be upper limit minus the lower limit. All right? So look at what Sir did. Let me just copy. Tell me if you agree with me moving from here to here. This negative sign, I just cut up to, because this negative 1 in the denominator makes my 2x to the negative first power negative. Matter of fact, you know what I should do? Let me do it. Because we say, but sir, why nobody does convert it and put it back down, right? So let me do it. Save you from the confusion. And to be honest with you, it looks neater. It looks way neater. Oh Lord. It's a good thing I come back here because I had a mistake right there. So what a good thing. All right, so what I've done here, this x to the negative first power, I flip it back into the denominator. So it becomes x to the positive power. Then I'm substituting my upper limit 2. So it's going to become negative 2 over 2 plus 5 times 2 squares over 2 minus 6 times 2 minus today's Tuesday or Monday, or Tuesday, minus the negative 2 over 1 plus 5 times 1 squared over 2 minus 6 times 1. You know, one of the things that when I was going to school used to confuse me, not that I didn't know what I'm doing, but because I was writing the question so well, I keep making that error, and I'm going to point it out to you, and I'm hoping none of you don't have that problem. I thought Sash was going to allude to that earlier, or maybe Krishna, one of the two. Oh, I need to fix this line. Let me just delete this line and copy that one back and paste it. I'll leave it there. When I'm substituting the values, I keep making, sometimes I get a mistake on because I'm going with the question so nicely and substitute the lower limit sometimes over the upper limit side. You have to be very careful. Be very careful that your upper limit is on the left-hand side and your lower limit is on the right-hand side. Every single time. The upper limit is on the left-hand side and the lower limit is on the right-hand side. -2 divided by 2 is going to be 1.
Sir,
Yes, honey.
I realize you're doing something different than what you did in the last class. And that is where I'm seeing the difference in my workout. You're canceling out right now, but you had used like the LCM and divided the denominator by it, and then multiply the numerator by the number.
Yeah,
Sasha, you can still do the LCM, Sasha.
I'm still going to do, but thank you very much, Charlene. I'm still using the LCM, Sash. So it's not anything different. I'm just see the line here now, Sash. So when I reach right here, I am now going to put in those two terms together. So like this one here now, I'm going to say -1 minus 12 is -13. So we have -13 plus 20 over 2. But 20 over 2 is what? Not 10.
Yeah.
Yeah. So let me just fix this one from now. Because 20 over 2 is 10. So once you can break it down, you break it down. So you have -1 plus 10 is +9, and +9 minus 12 is -3.
Yeah, I never know I could have done that prior.
Yeah, man. Yeah, man. Yeah, man. So we're just simplifying that. And then this side now is where we're going to have the issue. Because we're going to end up with now 4, -8. -8 plus 5 over 2. -8 plus 5 over 2. And when we find the LCM for that now, we're going to get -16 plus 5 over 2. And -16 plus 5 is a -11 over 2. And -11 over 2 times this minus 11 over 2, then it give me +11 over 2. So what I'll have is -3 plus 11 over 2.
Sir, how you get the -16?
Thanks for asking. This 8, this -8 is over 1, and the LCM is 2. 1 into 2 goes 2 times. Let me just put it there so it is that you can visualize it.
Okay.
This is an imaginary 1 that is there. 1 into 2 goes 2 times. 2 times -8 is -16. 2 into 2 goes 1, and 1 times 5 is 5. And then -16 plus 5 is going to be -11. But that -11 over 2 is being multiplied by a -1, so it becomes a +11 over 2. So now what I have is -3 plus 11 over 2. -3 plus 11 over 2, and I'm going to get something like, well, let me not even. 1 into 2 goes 2 times. 2 times -3 is -6. So I'm going to have -6 plus 11. And that is going to give me -5. Positive 5/2. Everybody got five halves?
Yes, sir.
Very good, Charles. Yannick, unmute me, please.
Yes, sir.
What want we do?
Okay, sir.
Can you, may I have back Yannick, please, for my class tonight? Who vex you?
I don't vex nobody, sir.
But you cannot vex nobody and come in my class, because you know, say, we need to hear from you, Yannick. This is not you. Oh, you
But
never
do
read so far.
Yeah,
You never.
no, so that you come with it. That's what I'm saying. No, sir, that you gonna come with.
So we also know Yannick. You got the 5 halves unit square for this one?
Yes, sir. It's only
Very
the
nice.
second one. But they get wrong because me in my brilliance, I'm dividing by the 3, but I put back the same power. So I divide by the correct power, but put back the wrong power up top. So, but so far everything is alright.
Very nice. I'm happy. Sean Anderson, 14.
Yes, sir.
Oh, so I do have to call it so many times, sir? Have you completed my assignment, sir?
That's just it, sir.
I don't hear you.
Not completely, sir. Not completely.
Okay. All right, thank you. Number 4 says x squared. Tonight, going to be a working night for you. So I'm going through these nice with you. I'm going to project some questions for you to do. And especially those of you who never finish off my homework, watch me at home. At the end of the semester, I must see passing grades and straight up. All right, so some of you will say to me, sir, I did not do the question in so many lines as you have. And that's fine. I keep saying to you, the reason I have so many lines is because I'm doing it step by step, so that when you're reading the document on your own, you can follow and not wonder, how did he move from here to here? I'm doing stepwise. So if in your brilliance, when you look at stuff, remember, I'm not going to say that you're just going to move from the question to the answer, And especially you can do that for the integration, I have no problem. But you show me you're working for the substitution, show me you're working for the evaluation. It's very important. One of the things I say to you, evaluate the upper limit first, then you go and evaluate the lower limit after, and then you subtract the lower limit from the upper limit and give me a final answer. Very, very important. You can't do the integration right, the substitution right, and then no, you can't work out something and get piece of the question wrong. Once you get the integration part right, you're supposed to get full marks to the question, because the other part of the question is little school mathematics. Little school mathematics. All right. I'm going to do the half an hour worth of work. So this one here now says, oh, this is easy, 1, 2, 3 to integrate. Add 1 to the power divided by the new power. There's so many times I'm saying it, because I want you to get it. There's so many times I'm saying it, because I want you to get it.
Sir, may I ask one stupid question, but I feel like somebody else has think about the same stupid question as me, so I'm gonna help them out. Upper limit is always bigger, right?
Very good.
Okay.
And even though I said it, let me say it again. That's why it is called the upper limit. The upper limit bigger than the lower limit. There is no question at all you will see unless it's a typo error, where the lower limit is going to be bigger than the upper limit. That's why it's called the upper limit. The bigger one up on top, the littler one at the bottom.
Sir,
yes,
if we do see a typo error like that, what should we do then?
Bring it to the attention of the examiner. Bring it to the attention of the examiner. Can't work. There's no way that can work. Math error.
So, sir, what if it's online? Who would we bring the attention to if it's online?
So if it is online, I used to something like that, and you say, boy, sir, you drop something on the WhatsApp group and say, sir, can you check question 2, please? You don't have to tell me what is the problem, because other people can see the messaging on the WhatsApp group. I mean, I go into the WhatsApp group and I see the error, I say, okay. And then no, I would say to exams, you know, so that question don't make no sense. And exams will have to do due diligence and say to CCCJ, rate it, and then CCJ say, Mr. Shan, how can we correct the question? And I said, why are you the plan? Make we flip with something, you know, and then that official word will come from our exams unit to say this is the situation. So that will come as an official email to the students who are doing online, if it's what I'm saying. All right, because the exam is being done right across the board, right across community colleges here in Jamaica and overseas. Go ahead, please. Somebody unmuted just now.
So therefore, we'll get a point for that, right, sir?
Say it again, Papa.
Therefore, we'll just get a free marks for that one, right?
No, sir. If it's like that, all right. So say nobody recognizes that there's an error. But you know, you went through and did the question. I can prorate the question by saying, okay, 1, the student did the integration correctly. So if it's a 5 marker and there were 3 marks for the integration, the students would have gotten the 3 marks for the integration. All right. And then now, if there was 1 mark for substitution and 1 mark for the final answer, once you would have substituted the incorrect values correctly, you get that 1 mark. And your answer would have been wrong, we can award that 1 mark. So instead of giving you 4 out of 5, we'd have given you 5 out of 5. So what would have done then is that once the student would have made the substitution correctly, we just award the student 2 marks at that point and don't look at the answer. If it's what I'm saying. I don't know if I'm making any sense. All right, watch me. Watch me. So if I'm saying to you that the question carries 5 marks, but of the 5 marks, 3 marks here would be awarded to the integration. The student would have gotten the 3 marks here. But guess what? The 1 was up here and the 2 was down here. So the student see the error, but no information came. And then after that, now the student put the 1 over this side and the 2 over this side because the error came. And the final answer therefore is wrong. What we'll do is give the student the 3 marks here. And because we know it's no fault of the student, right here we would have awarded 1 mark, would have just awarded the 2 marks. So you end up getting full marks for the question. Once it is, that everything else is done. Now, I keep saying to students, if you're going an exam and there's an error with a question, don't just leave out the question and say error, because we can't award you any mark because we said that, okay, the student didn't do the question. No, if you attempt the question and we can see where it is that you would have attempted the question and attempted the question correctly, even though the question was poorly written or whatever the situation is, you can get your full marks for the question. But we can't give you full marks if it is that we don't see any evidence that you attempted the question, whether or not you attempted it on paper and throw it away.
That's it. I want to give you wrong information. I will not say it wrong, so I may go waste my time do it.
So what about those students who just don't know for the question there and just say them not touch a question there? What will happen? So the point I'm making, Kels, is that whenever you get a question, put evidence on paper. Before say that to try something. Try something. Put some, and say, third question incorrect, or say something. Just put the paper, the question on paper, so we know what is happening. It's just like if you went and bought food at a restaurant, and somebody else bought the food at the restaurant, and the person eat the food and gets sick, but you somehow got home and feel tired and never ate the food. And then after that, no, the food's still in the fridge and here's a boy, the person's sick. You don't have no compensation for get because you never eat the food. So the person who gets sick, no, the restaurant may say, here the plan, I apologize for what has happened. I'm going to give you 10,000 US dollars. And the person may say, yeah, possibly $10,000 because we never forgot hospital. Really, it's just that it give me a little loose bowels, but I'm good now after that. So pass on the $10,000. I can't work with 10,000. Trust me. I'm sure. Well, I know I could do well with 10,000 US dollars right now. I could do 10,000 US things with it. All right. So, but if you, Calvita, never eat the food, and you're going to say, you know, I also bought the food and said, oh my goodness, did you go to the emergency room? No, I never ate the food. We don't have nothing to get. It's something.
I'm not going to tell you whether I not meet the food, yes or no.
There is a God who will deliver. But you see the point I'm making though, right? Because I mean, in order for you to get compensation, you know, you have to go to emergency room to show them that, boy, you had an adverse effect, you know, from eating the food. They can't just tell them, say, oh, I became sick, and you have to go, and this is your proof. This is a proof. So the medical practitioner will say to you, yeah, this person had a bit of the loose bowels, and the test indicated that the person did well. Yeah, man, you're covered. Because all and sundry can come and say, me to buy the food and eat the food too, and then I forgot pure, and then the company runs into bankruptcy. So we'll have to have evidence in order for you to give the stuff. And which is why I'm saying you have to have evidence for the question. So it is that we can give you the mark for it. It's real talk, real talk. All right. All right, thanks for those questions. They are very useful. Cuatro, numero cuatro. It's x squared plus 7x plus 6. I've integrated, so I'm going to get x cubed over 3 plus 7x squares over 2 plus 6x. My upper limit is 0. Whoa, sir. Upper limit can be 0, sir. Yeah, man, because the lower limit is -1. But, sir, oh, yes, sir. 0 is a bigger number than -1. You see it now, sir. Yeah, man. Every single time. So, anywhere in the function for the upper limit, you see x, you're going to substitute 0. So you have to write it. I'm going to caution you and say yes, because sometimes not all of the terms will go to 0, depending on the function you're given. And it has happened to me where you get overly excited and you make a grave error. You don't want that to be the case. So you do what it is that you need to. Okay, I need to remove my limits because I've already made a substitution. So let me just remove those. And then look at that and tell me if you agree. Look at that, tell me if you agree.
Yes, sir.
Yes, sir.
Very nice. Very nice. Very nice. Oh, them people, man. No, like seriously. 3 killed, 8 hurt in shooting at Michigan High School. 15-year-old boy. What is wrong? Come on, no, man. We must just go easy. We're tired of this game now. John must die. People them look forward to Christmas and no Christmas to them now. Never easy, man. Sure. Aye. All right. Now, when we investigate the upper limit side, we recognize that everything goes to 0. Do you agree with that? Anybody? Somebody? Háblame. And then it's now reduced to this. So all of this goes to 0. 0 over 3 is 0. 0 over 2 is 0. And 6 times 0 is also 0. So all of that goes to 0. Negative 1 cubed is going to be negative 1, so it's going to be negative 1/3. And negative 1 squared is 1. 1 times 7 is 7, so it's going to be 7/2. And this here, positive 6 times negative 1 is a negative 6. So we are now going to find Miss Sash, since you asked the question. We are going to find the LCM. And the LCM here is going to be 6, if you agree. 3 into 6 goes 2 times, and 2 times negative 1 is negative 2. And 2 into 6 goes 3 times, and 3 times 7 is 21. So that will be plus 21. And then 1 into 6 goes 6 times, and 6 is 36, so that's minus 36. So look again, Sash, and I'm only calling upon you because you asked a question earlier. The LCM here is going to be 6. 3 into 6 goes 2 times. 2 times negative 1 is negative 2. 2 into 6 goes 3 times, and 3 times 7 is going to be 21. There's an imaginary 1 under the 6. Any whole number can be written as a rational number by dividing that number by 1. So there's a 1 under here. So 1 into 6 goes 6 times, and 6 times negative 6 is negative 36. So this is what I ended up with. Krishna, how are we?
Yeah, I have that, sir.
Like this one. Be liking this, sir.
All right, cool. Thanks, Sash. And then when I add up all of that, I'm going to get something like negative 17/6. And all of that is being multiplied by a negative sign. So it's going to become 17/6. Everybody got 17/6?
Yes, sir.
Very nice. You see what happens when the homework is done? People get better at doing it. Oh, supposed to be positive 17/6, Mr. Sir. There you go. Very nice. I'm very proud of you guys. Very, 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 very proud of you guys. Let me stop right here and ask the question. Is there anybody in the class that is still not following what is happening? I've been gone through 14, 15. I've been gone through 4 of those questions already. Is there anyone in the class that is not following?
Harder?
Say it again, Papa.
Does it get any harder than this?
It really doesn't. It really doesn't. The truth is, I can give you, and I mean, that is going to be the add-on for come next class. Next class, I'm going to give you things like when the function is negative 1, and then we have the ln function there, right? So you're going to have something else to do when the ln function is there. Then I'm going to give you the exponential function, right? So I'm just going to give you several different functions, and then I'm going to give you one where you can't integrate it as it is. You have to use a substitution. So I'm going to teach you the substitution method for integration, right? But for the most part, really, what it is that I would have completed with you, you will go into the exam out of those 30 multiple choice questions that you're going to get. You'll go into the exam, and trust me, about 5 of those questions on the multiple choice already, you will know how to do based on the integration. You're going to get those to integrate that are indefinite, and you're going to get those to integrate that are definite. So if you understand this so far, trust me, you are on a good path. And if you understand this so far, it's when I move to applications of the integration, you already have it packed. The applications of the integration is exactly like what it is that we're doing now, with the exception that they're going to give you a graph to just look at, and you're going to plot it from the, you're going to interpret the graph and just write on something. It's the exact thing that we're doing right about now. So yeah, man, it not get harder than this. And I'm being honest. I'm here to motivate you. So don't say, yes, sir, you can't say it because you're the teacher. No, man. And that's why I took the time out, Krish, to make sure that you understand the indefinite one. And then when I was feeling very excited to the point where I called my assistant and was talking to her and saying to her, I said, no, man, I'm looking for big things for my Calculus 1 group. I'm chatting enough, you know. But let me tell you something. Disappoint me, I'm going to see what will happen. You understand? Because me both about on you know. Right? So that's why when you're not doing what you're supposed to do, I come and I feel up. Yes, Miss Kells.
Sir.
Yes, Miss Kells.
Why you feel say you must put Wally Pepper Shop away?
Okay. All me I tell you say is a threat. It's a threat. Me no want to see minus. Me no want to
near
see.
you know.
And me no want
so
to
I come in
people.
and know how much me getting at the test already. Now what near you? Because you don't even tell me if I pass or I fail.
And you know, clearly you don't listen to the recording yet. Aha. That's how I know you don't listen to the recordings. Ha 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 ha. Because I would have said something in the recordings for you to know what grade they got, but it's just that they can't get the paper. Ha ha ha. Your secret just burst. But yeah, man. So just make sure they do what they're supposed to do, you know. That's all I'm asking. Make sure they do what they're supposed to do. All right, let's go. So here goes. Is there any question? Is there something that is not too clear? And it's a Yannick a while ago, see something, you know, and she say, you know what? I'm going to ask it, and it may sound stupid, but I'm going to ask it. And she asked, sir, the upper limit must always be bigger than the lower limit. If there's something that you're not too certain about, don't move away from the class tonight with a possible misconception. Ask the question.
For me, work with being the idiot. Me ask a foolish question.
Thank you very much, Sudan. Trust me, I like you. Yes, please.
Go up. The second question.
The second question, 4, 3. This is the second one.
The when you get the 4 over 3, and you get it to the answer. Go down to the answer now, sir. Right this so. I still don't know how you get the 2/3 there. Because it would be, wouldn't you find the LCM of that in the bracket? Yes.
You know, may I talk to you? And I'm muted. Senior moment.
Oh, all the way I get all.
Yeah, I never. No, you're alone. Go away.
Me all.
All right. So the LCM here. Remember, there's an imaginary one under here. All right. So so your question now, Kels, just supports the point. I was actually cutting a line right there because I thought you guys would have seen it. So let me put in that line and you can see. The LCM is 3.
I see it in but for some reason,
That's fine. That's fine. That's fine, honey. 1 into 3 into 3 goes 1 time, and 1 times 1 is 1, and 1 into 3 goes 3 times, and 3 times 1 is 3. So I'm going to have 1 plus 3. And similarly, I'm going to have plus 3. All right, see there now, honey. It's supposed to sit a little better now. So the LCM here is 3. So 3 into 3 goes 1 time, and 1 times 1 is this 1. This imaginary one that is down here into 3 goes 3 times, and 3 times 1 is 3, which is this 3 up here, and 3 plus 1 is 4. Similarly, 3 into 3 goes 1 time, 1 times -1 is -1, and this imaginary one that is here into 3 goes 3 times, and 3 times this 1 is 3. So I have this 3 right here.
Just see my mistake.
Absolutely, and that it supports the point that I'm making, because I did not write that line. Because, you know, I just skipping out that line. I just never wrote it. But now that I put the line in there, you're seeing what it is that I'm having. Oh, Lord. And I'm happy that you're now seeing it. All right. Finale.
final one is x cubed minus 2x squared plus 4x minus 5. Lower limit is 2, upper limit is 3, and I'm going to be integrating. You add 1 to the power divided by the new power. Is so many times I say it. I sound like a broken, a scratched record. I sound like a very scratched LP. But I'm doing it because I want you guys to hear it, since we learn by repetition. But some of you hearing, but you're not seeing. You have to follow what teacher is doing in order to get it. And it's 3, 2. Look at that and tell me if you agree.
I agree.
All right, good job.
Yes, sir.
Nice.
Yes, sir.
Very nice. All right, now that you have agreed with me, what we're going to be doing now is to anywhere in the function, I see x, I'm going to substitute my upper limit. And then I'm going to do the same thing for the lower limit. And I'm going to subtract 1 from the other. Upper limit minus the lower limit. I can't overemphasize that point. You do not substitute before you integrate. You must integrate first before you substitute. I've seen students get a question and just substitute the upper limit and lower limit and think them get full marks. Does not work like that. All right, this one is a little long. All right. So I need to remove this here because I've already done the substitution. And I do the same thing for that one. And then 3 to the 4th is 81. Talk to me.
Yes, sir.
And 3 3 is 9, 9 3 is 27. And 27 times 2 is 54. And 3 3 is 9, and 4 9 is 36. And 3 times 5 is 15. So what I'm doing some of the calculation in my head and not writing as many lines as I did before. As we go 2 2 is 4, 4 4 is 16. As we go into the question, you'll see what was happening. 2 to the 3rd power is 8, and 8 times 2 is 16. And 2 2 is 4, and 4 4 is 16. No, what are them 16? And then 5 times 2 is 10. Yes, honey. What's up?
I do it again, sir.
What we do?
Sir, that made it up and then earlier on, I see where you cancel the 4, right? And leave it at 2.
Same difference. Okay, fine. So that's what you have? Okay, don't worry about it. Hold on.
Time to change up the answer of what you have now.
Okay, that's fine. It is, as I said before, you will get the same answer in Sash. You will get the same answer as, okay, you know what? I am not going to cancel out there. Answer spelled wrong. Right? So notice that we have not cancelled the common terms. We will update, we will check to see if we get the same answer. Let's see if we'll obtain the correct answer. So some of you may can't see that. So I'm saying to you, we only cancel because it makes the calculation so much easier for us. Because when I have, which one is it? The one here now? When I have 36 over 2, I could have just said 3 3 is 9, 9 9 2 is 18. So this one would have worked out to be 18 for me right there and then. Now I have 36 over 2, which is the same 18. So it's not going to make a big difference, really, no. Really not going to make a big difference. But I see your point though. And I can't do the question one way, Sash. I have to try and find, variable ways in doing the question so you can, be great at it. So that's going to be 8, so and it's going to be 4. 16 over 3 have to remain. 36 over 2 is 18. 54 over 3 can work as 24, No, 50 over 18. 3 8 24, so that's going to be negative 18. And look at me if you agree with that. Nobody talking to me? Is it that you're not in agreement with what I have? Or is it?
You cancel that line.
You cancel the 9? What 9?
The line, that line that you have that before you cross out.
Okay, fine, fair enough. Fair enough. Maybe fair enough. 4 plus 8 is 12, and 12 minus 10 is 2. Then the LCM is going to be 4. 4 into 8 to 1 goes, 4 into 4 goes 1 time, and 1 times 8 to 1 is 8 to 1. And 1 into 4 goes 4 times, and 4 times negative 15 is negative 60. And the LCM here is 3. 1 into 3 goes 3 times, and 3 times 2 is 6. 6 minus 16. And 8 to 1 minus 6 is going to be 21, I believe. And 6 minus 16 is going to be negative 10. And that now becomes positive 10 over 3, if you can agree with me.
Let me have big wrong bang.
No way.
When I get that.
Anybody else has what I have?
Close. Yeah.
All right, let us see what let me just finish the final answer and then do the stuff.
Yeah,
So,
105 over 12, sir.
105 over 12?
Yeah.
All right, that sounds correct. So the LCM is going to be 12.
I have 1 over 3, 103 over 12.
Yes,
right.
That's what I have to, sir.
Okay then. All right. Let us check. So 4 into, that's why I said don't do anything yet, Sash. 4 into 12, the LCM is 12. So 4 into 12 goes 3 times, and 3 times 21 is going to be 63. So up here is going to be 63. right? And then now we're going to have 3 into 12 goes 4 times, and 4 times 10 is 40. You know, so 103, a 103 not Jermaine. And 40 plus 6 is 3.
Yeah, 103 for sure.
A 103 over 12.
Yeah.
Tash.
Oh, okay.
Tash.
Yes, sir.
Leave me alone here. Don't trouble me.
Well, it's good to know that I can have 2 different
ways of doing it.
Right.
Right. Very good. Very nice. 103 over 12. Very nice, guys. I was hoping.
Oh yeah, sing too.
No, a song just pop up in my head from evening, and every now and again it keeps coming up, and every time I start humming it, I remember that I'm in class. So forgive me. You know the song? Okay, no, you don't.
No, sir. So I'm asked how we are singing too.
Trust me. All right. Papa Jesus. It's called Amen, Amen. All right. Yeah. You know, the truth is, you guys, there you go. Those are the 5 questions. No, who get all 5 right?
Me, sir.
Good. 1. Anybody else?
Got 4. Can't get last one wrong.
Yeah, okay, 4. Yannick, you got 5. Okay, Yannick, you got 4 or.
Sir, I'm gonna get this wrong too.
Yannick, well, you see where it went wrong though.
I left off the 3. When
okay.
I did
The
over
LCM.
the side, I left off the 3.
The 3. Okay, fair enough. Got you.
Sir, the question x squared plus 7x plus 6. What was the answer again?
I'll tell you in just a few. 17 over 6.
So my 114 over 6, that wrong too?
Yeah.
Right.
No, which one? You got 14 over 6?
No, 114 over 6.
It would be 114 over 6. It will be 114 over 6. It will be 2156. It will be 2156. So 114 over 6, you know, is going to be 20 over 6.
Okay.
Yeah, so double check on that one for me, please. Did anyone, hurry. Did anybody get all 8 incorrect? I mean, what am I talking about 8? Forgive me. My mind is going somewhere else. Forgive me. Is there anyone in the class that didn't get any one of them right? You notice, I'm going to call out them people right now. Me notice them people that in the S people them in my class. Miss Smith, Miss Wint, and Mr. Anderson. If we not call upon on a tree, we not talk to teacher, you know. And we always their class. And we want to hear from on a tree. S, and S.
May I explain?
No man, you're talking about.
Sir,
You know what?
sir, sometimes my background not conducive to talking.
Sometimes your environment is not conducive to talking.
Exactly.
No, but sweetheart, that the first me I hear that.
What? All right.
No, so no, but if you not you know, as a woman say, no, guys, let me tell you how women stay. They expect you as a male to get into them headspace. Okay, I'm not speaking, so he must know that my environment is not conducive to talking. No, you have to tell me.
So let me go answer.
Yeah, man. So you have to tell me.
Be quiet.
No, man. So now that I know, I won't trouble you. So you have to go now talk in the chat. Okay, can't be Let me not even go there. So what about the other one? Miss Wint, what you say? Still not say, but anyhow. Yeah, I'm feeling good. There are 3 students that are absent. 21. 4 students that are absent. 3 students that are absent.
Sir, me not cut you, but no, I guess me not go wake up and do any more homework again. I go cool off for half an hour because them limits, your upper limits and lower limits, totally different from your one, sir.
Okay. You will be fine. You'll be fine. But no, what is important though, Sash, is that I like what I'm hearing, that you're getting up. Because when you get up, a lot of people say that math's not supposed to do a night, and how you can have math class at night. Math can work at night, once it is that the environment is, for want of a better word, conducive for learning. And I'm trying to create that sort of environment for you. All right. Now, you see, when you sleep and your brain fresh, yeah, man, that's the time now, it is good for us digest 1 or 2 math questions. It's very important. So get up, man. Get up still and do something. What I do, Sash, and I'm not suggesting that you need to do it, but what I do, from ever since I started studying, I am a tea person. I mean, I love the sexy teas. They say the exotic teas they give me, the maple leaf and them pretty something there when
what kind of tea, sir?
No man, trust me, them are some very nice. Them are some nice. Yeah man, sexy tea, man, sexy tea. Yeah man, them are some nice sexy tea with them on. The Earl Greys and the oh goodness, the green leaf and them something there. Wow, yeah man. So I drink a lot of teas, and what it does sometimes, and the chamomile, it relaxes the mind. It just puts you in a different trance to just get some work done in the same process it does.
Source leaf tea good, sir.
Source of leaf tea is also very good, and the mint tea, the honey mint will grow your yard, and the peppermint will grow your yard is very good. And if you mix the honey mint and the pepper tea and the peppermint tea, mint, and you make a tea out of it, it is equally as good. But just find something. I'm not going to suggest to you that you need to snack, because every time you're studying, you don't want to snack, and I don't want you to lose your slimness. So, but find what works for you. What also worked for me when I was studying, I used to get up when my siblings are all asleep and everybody's asleep, and then I would go into the living room, turn on the television, because I have to have, for me, I can't study when it is pure quiet. So I have to be on, like, them used to run CNN news the whole night, and the same news I repeat after the first 45 minutes, so we can't tell you exactly what come next in the story. But at least I have the television there to just keep my company so that I don't fall asleep, and I get a lot of work done. When I'm finished, I used to go and buy packs of folder paper, and I just work the questions. So it's like, how we do them something here now. We write the question, check the book, and work the question on my own. And if I stuck, I open the book and look and say, oh crap, I never do this part, I never do that. And then I write the question again, check the book one more time, and work the question. And I do this as many times as it becomes necessary for me to get the question right, and just practice. I'm telling you, you see the work that you put in now, students, you will never regret it, because you don't have to put in that much work when it's time for the exam, because you would have already put in a whole lot of work. All you now need to do is just put the icing on the cake. The cake is already baked. All right? So do what it is that you need to do. If you don't, you're going to be in serious problems. All right. Peace and salutations. Study hard, please, guys. I really am depending on you. Trust me, anybody who disappoint me, I am gonna have you up. I speak about you with the highest regard to your head of school, to my colleagues. No, leave me alone.
Sir, you're Christian enough to have up nobody.
And me to tell you, no, this is good have up. Jesus will be very pleased, right?
No, I'm not pleased.
And I speak proudly about you. The other day I was showing some students how to do their mid-semester and how to attach their stuff to their stuff. And I'm going to confess something to you. And of course, which class I go for? Phone class. We could have go for another class. I said, no. I went for phone class and I showed them the stuff, and I was like, and this is what my students did. And then no, they don't know, they get into me.
me deleting something from the work that you uploaded to me. But it's not an issue because I had already marked those and I had already planned to substitute those marked pieces with the ones that you uploaded to me, right? So I just need to do some work right there. But I'm just saying to you, I speak highly of you. And as a result of that, I really want you guys to not disappoint me. Because I'm sure if I wasn't doing what I was supposed to be doing every day on a complaint, well, not actually not complaining, but you know, if things are not going right, you're going to complain and say, sir, not delivering. Know that if I'm delivering, I want to see the results. If I'm not delivering, you need to talk to me and say, sir, I think you can do better in this regard, whatever the situation is, and I can work on it. But anyhow.
I have a question, sir, before you leave.
Sure.
So I want to know, sir, is it that you will be modifying the questions on it because of, or no?
All right, so this is what is going to happen. I tried actually doing this stuff and they weren't coming out. And then when I touched base with Educate International, because some students have already done some pieces of work, the thing that I would have been corrected will not take effect. Well, will only take effect if I close out this assessment to put on new assessments. And I don't want to disenfranchise those students. Thanks for asking the question. I didn't remember to say to you, I don't want to disenfranchise those students who would have already completed some pieces of assessment. So which is why I was saying, move on and leave those alone. I will modify those by giving you something else to do in place of those. So move on to the other areas.
So I go in the units, right? And the homework and the quiz. And I found upon some things that I don't see you do, sir. I should leave it alone.
All right, hold on. Which one is that? Which
sir, the sine and the cosine and
that's what I'm saying.
Cut on them something.
Okay, that's what I'm saying. That's what I'm saying. Anything that you're seeing with the trigonometric ratios, do not do those.
Sir, but then all over.
Don't worry about it. Just I'm gonna ask.
But that not gonna bring down your grade.
No man, hold on, no man, just work with me. So I'm gonna ask. No, hold on, no man. So I'm gonna ask you I'm gonna ask you to record for me, and if I get it from more than one person, it's not a problem. I want each of you to record. When you go to the assessment, just record for me and say to me, sir, one of those trigonometric ratios is contained in here so that I can prorate the grades that you'd have gotten. You follow what I'm saying? So if you're doing one of the assessments and you get 5 questions, and 4 out of the 5 questions are okay, but the 1 question have the cotan function, and when you do it, you get 80%. Just record it and give it to me so that when I am amalgamating those grades, I can say I am prorating this one. So instead of giving you 80, I can go in and change it and give you 100%. So this is the best I can do. Yeah, man, this is the best I can do for you at this point in time. But I really want you guys to move on and try completing those assessments.
All right, sir.
Bless your heart. Bless your heart. Take care.
Thank you. Have a good night.
You too.
Night.
Night.